So in this video, we're being asked to find the outcome of a lottery game. Now, in this lottery game, there's several different prizes available. The first prize available is a $900 prize, and there is one of them. Right? One $900 prize. There's also one $500 prize. However, there's two $300 prizes and five $200 prizes. Okay, so I've got 1, 2, 3, 4, and then another 5. So I've got 9 total prizes, 9 total options of what we can win. Some of them are duplicates. Now, it also says that there are 1,000 tickets sold at $5 each. Okay, find the expectation if a person buys 5 tickets. Okay, assume that the player's ticket is replaced. I'm going to highlight this because right here, this statement right here is essentially saying that each time a ticket is pulled, the game is reset because the ticket goes back in and that same ticket can win again. So everything is back to normal. What we want to do in this problem is we don't want to focus on the buying 5 tickets yet. We just want to look at what is the outcome of a single ticket being drawn. To do that, we create our probability distribution. We first list our outcomes. I'm either going to win 900, 500, 300, or $200. Okay, so these are my outcomes. The question is now, what are the probabilities of my outcomes? Well, the probability of earning $900 or winning $900, right? Well, there's 1,000 tickets and there's one ticket that wins that. So there's a 1 out of 1,000 probability that you get that ticket, that you win the 900. What about the 500? The same is true there. There's 1 out of 1,000 that you win that $500 prize. There's 2 $300 prizes, so that's 2 out of 1,000. And there's 5 $200 prizes, so that's 5 out of 1,000. Now, some of you might be saying, wait, there is a 5th outcome. And you're correct. That 5th outcome is you don't win anything. Right? I have 5, 6, 7, 8, 9 outcomes out of the 1,000. So that means I actually have 991 times out of 1,000 that I don't win anything. I win 0. Okay, so we now have our probability distribution here, the outcomes and their associated probabilities. In order to find your expected outcome, all right, expected outcome, what do? We take each of our outcomes, multiply it by its associated probability, and then we add them. So let's go ahead and do that. 900 times 1 over 1,000 is 900 over 1,000. Okay? 500 times 1 over 1,000 is 500 over 1,000. We'll simplify those here in a moment. 300 times 2 over 1,000, that would be 600 over 1,000. 200 times 5 over 1,000, that's actually going to be 1,000 over 1,000 when you do the multiplication. Last but not least, 0 times who cares is 0. So let's go ahead and add these up. Well, they all have a denominator of 0, so I'm going to keep that as the denominator. We do 1,000 plus 600 is 1,600, plus 500 is 2,100, plus 900 is 3,000. Well, 3,000 divided by 1,000 equals 3. Okay, so your expected value, the expected prize that you win for playing once is $3. Here's the problem. How much did it cost to play the game? It cost $5 to play the game. So I know that my expected outcome is the $5. Well, let me actually do it this way. We're going to win the $3 minus the $5 I had to pay to play. So what is my expected outcome? The expected outcome is every time that I play this game, I expect to lose $2. Now, every once in a while, I'm going to have this big win, but the vast majority of the time, I'm actually going to get $0 but pay $5. So I'm actually losing $5 every time I play the game unless I actually win one of the prizes. So the expected outcome every time you play this game is negative $2. Sometimes you win, but more often than not, you lose. Now, the last piece of this is that piece right here where it says find the expected value if a person buys 5 tickets. And what's happening, assume that the player's tickets is replaced after each draw and that the same ticket can win more than one prize. Right? So if we're playing this 5 times and I expect to lose $2 every time that I play it, right? What is my overall expectation if I buy 5 tickets? 5 times negative 2, which equals negative $10. So I expect that if I buy 5 tickets, I will lose a total of $10.